Hi, I'm Karl Newell. I'm a network software architect at Internet2, and I'm going to talk about network automation and orchestration at Internet2. We recently completed a nationwide upgrade of our network, and I'd like to highlight how Cisco NSO and other Cisco tools contributed to our success. I'd also like to thank Cisco for inviting me to present. First, a little bit of background about Internet2. We are a community-driven organization with a focus on research and education. We run a nationwide network across the US. And while we also offer many services to our community, like connections to cloud providers and assistance with cloud contracting, I'm going to focus on our packet network for this talk. So this is an image of our nationwide network. We have a fiber footprint across the country. On top of that, we run an optical system based on the Sienna 6500 and Waveserver platforms. And our packet network is now based on the Cisco 8200s, which is a silicon ASIC. This is a recent generation chip from Cisco. This generation is 10 terabits per second with 400 gig ports, meaning we run a 400 gig backbone. Over 2020 and 2021, we actually migrated to this network. We used to run a Juniper MX network, a 100 gig network across the country. And so this talk is going to focus on migrating from that Juniper network to the Cisco network and how NSO and other Cisco tools helped us with that migration. We also have a handful of Cisco NCS gear at our Cloud Connect peering sites and ASRs and XRVs for route reflectors. We also run a parallel management network based on Juniper hardware, the X4600 and the SRX 1500. And we manage that with NSO, but I'm not going to focus on that for this talk. All of our configuration on our main core packet network is managed by NSO. This includes the base configuration and all of our edge services. And a big highlight of the migration was that with NSO and other tooling, we were able to migrate over 2,000 BGP peers in about 30 days. This was in 2021. So real quick about why Internet2 chose NSO. I think the first two bullet points for most folks familiar with NSO are pretty obvious, so I'm going to focus on the last three. Number one was coexistence with out-of-band changes. So during our migration, not only were we introducing an automation platform, something we hadn't really had before, any kind of tooling for automation, but we're also migrating vendors and CLIs. So we're going from Juniper Junos to Cisco iOS XR. And a lot of our engineers had no experience with iOS XR. So we needed a system that can handle out-of-band changes because engineers might not be familiar with the automation system and might need to make a change, and they can go directly in the router and make that change. We also knew we weren't going to get all of our service models correct initially, so changes would have to happen out of band. And Cisco really allowed us to automate the network and handle those out-of-band changes. And also, this really leads into the graceful evolution over time of our service models. As we determine what we missed in a service model, it was easy for us to upgrade and roll that out to the network. And a big part of NSO for us was the command line interface. For us, this is a first-class citizen in our network, and it made it really easy for engineers to migrate not only to the platform, but also migrate from Juniper to Cisco. Most engineers are very familiar with the CLI, and they were able to log in and quickly become familiar with NSO. And there were a lot of things that engineers were doing that I wasn't even expecting them to do with NSO, like using live status to pull operational data from the network. And I would like to highlight a few of the success factors for our migration and why we were successful. The number one, and this is the one I talk about whenever I talk about why we were successful, was the integration of our network and development teams. We didn't have just a development team that was gathering requirements, would go off for 6 months, build something, come back, show it off, and that probably wasn't exactly the tool that the network team needed. So we were meeting once a week with a design team, with network engineers and the software development team. We still meet once a week to go over NSO models, and it wasn't just those meetings. Like as we were doing a lot of our development, we were constantly, meeting with the users, constantly discussing it, and always iterating. So, the development team would, put together a service model and go back quickly to the engineers and say, does this look good? And they would recommend changes. and we'd integrate that to the service model. And so that really helped. And actually, a lot of our development team, came out of our network engineering team. Before we really embarked on this migration and this automation project, we didn't have a software development team at Internet2, at least in the network services division. And so a few of us started development there, and then we started hiring people. And as you can see, we have, I'd say we have the quintessential DevOps team. We have people with a lot of different backgrounds that, cross all the areas of network engineering, system administration, development. And actually, what's really cool is we have a few people doing user experience. So we're starting to build a portal on top of NSO and some of our other tools. And it's really interesting to have somebody that's focused on the user experience and the UI, talking to our end users, which is our members out there, seeing what they need from a portal. All right, so now I'm going to get into some of the details of our network migration from our legacy network to our Cisco network, leveraging NSO and some other tooling. As I mentioned, all of our services are modeled in NSO. We also migrated, as I mentioned, we migrated about 2,000 BGP peerings in 30 days using NSO and some other tooling, and I'll cover that in a later slide. And as part of that migration, we leveraged pyATS from Cisco for validation. We also tried to do test-driven development. And for this, we used the robot framework. So especially for a lot of our constraints within our NSO Yang models, or constraints within our Python code, we try to add robot tests so that we can detect if we've had any regression. And those robot tests run every time we push code to our Git repo with our CI pipeline. And we also, use NSO for configuration control and monitoring. So, as I mentioned, out-of-band changes happen, and we take advantage of this. We have processes that run a couple of times a week to detect drift in our network, and we see where changes have been made. And we use that as an opportunity to explore why those changes were made. We talk to the engineer. Maybe they didn't understand that configuration was handled by an NSO service model, or maybe it wasn't. And we try to figure out why they wanted to make that change, and we can bring that to an architecture team. And then we can decide if that's a valid change to our network, and we can integrate that into our service model and then push it out to the network. So as I mentioned, we migrated from our Juniper MX to a Cisco 8200 network. So how do we do this? The biggest challenge was our Juniper network wasn't under configuration control or any automation, so we had a lot of bespoke config around the network. Engineers using different golden templates to push different kinds of config to places. So we had to figure out how to standardize that. We also have a custom DB that some of our data comes from. So we wrote some scripts to extract data from our legacy network and extract data from the custom DB, and this produces a CSV file. And initially, we were thinking we would just take that data, run it through some Python script, generate NSO configuration, and push it out to NSO. But we needed a way for engineers to look at that data and possibly modify it. Maybe some services didn't need to get migrated. Maybe services were missing data, or they had incorrect data. So we needed a tool to allow engineers to work with that. So we actually decided on Google Sheets for this purpose. So an engineer could take the data extraction from our legacy network and our DB, paste it into Google Sheets. We then had an app script in the background that could read in that data, because now you have structured data, and convert that to NSO service models on another tab in that sheet. Engineers would then be able to take that, copy that data, and paste it into NSO for their migrations. So this really helped. One, it gave engineers familiarity with what these service models look like. It also, some of the app script could highlight problems in the original incoming data. Maybe it was missing route policy, or it's missing some community tags. So an engineer had the opportunity to fix that up before pushing it out to NSO. This process also generated the input data to our various validation scripts for pyATS. And so we use these for pre and post migration for BGP data. So we had our Juniper, when we deployed our Cisco network, it was deployed in parallel to our Juniper network. So we were able to cut customers over, basically based on a site and the customer. So we would go, a couple engineers would be on the call for the migration window. usually as well as the members to join us to monitor from their side. So an engineer would run the pre-migration scripts, which is, again, using pyATS to log into the Juniper networks, collect all the routes received, all the routes rejected, and standardize those into a data file. We'd migrate the network, wait a few minutes, watch for BGP sessions to come up, and then another engineer would run the pyATS post-migration script against the Cisco network, collect all that same data, again, standardized, and then run the script one more time in basically a diff mode and see what was different between pre and post migration. And this on this slide is an example of what we would see. In pre-migration, we were accepting, 5 routes. Post-migration, those routes weren't showing up. So, we could spend time to investigate or ask the member if this is something we needed to handle that night, or we could, wait till the next day and do it during business hours. And then, the big part of this is, there's lots of data here. It could be thousands of routes. We don't need engineers looking down a list of all that. So we try to put some intelligence into the script, and automatically skip routes, especially for data that doesn't change, no need to investigate. So this really helped us with our migrations. And this is why we're able to do so many. And while near the end of our migration, we were doing about 150 BGP peers a night. In the beginning, this script produced lots of data because we had things wrong. We had route policy wrong. We were getting used to Cisco RPL. So things weren't always, didn't work as we expected them to. But this really helped us focus very quickly on the routes that had issues and make the modifications to our network. And then again, by the end, 150 BGP peers, I think we did it in about 30 minutes with almost, no data showing up in one of these diff reports. So here's a little bit, stats on our development. And the main reason I put this slide up is this config compression ratio that I'll explain. And then I mentioned it in another talk, and an engineer really liked it. So I figured I'd include it here. So if you think about it, how many, there's a certain amount of lines of config that you put into NSO that maybe an engineer is typing in manually, or you have an automation process putting those in for you. So for us, that's 32,000 lines of config. Even that's a little misleading. We have stack services. Some of those lines of config are actually coming from the parent services. And a lot of that is actually also driven by some of our other automation platforms for circuit provisioning on our network. But that, results in 250,000 lines of config pushed actually out to our devices. So we have a config compression ratio here of 7.81, or let's say 8. So that's a factor of 8. That's how much configuration an engineer is not manually pushing out into the network. And so you can start thinking about that. That's reducing complexity in what an engineer is doing, and hopefully improving the efficiency of the configuration in your network. And actually, this the graphic at the bottom was interesting. I pulled it out for this presentation and hadn't really looked at it before, but you can sort of see where a lot of our work was happening as we were doing this migration. We are just prepping, getting used to NSO. This was the end of 2020. You can see a little bit of work, then the holiday break, and then work really ramps up as we're rolling out our new network using NSO to push out base configuration. Then actually July, we took a break. The whole division just took a break, took a couple weeks off to take a breath and get ready for our migrations. We have our new network deployed, but we haven't yet migrated any services over to it. And then you can see just a flurry of activity as we are working on our service migrations and working on our code and improving things. And then, just over time, just constant, NSO work, a lot of, feature requests and maintenance. And then towards the middle of this year, over the summer, a lot of our work to bring on our management network into NSO. So I talked a little bit about success and how NSO was really like a key part of what we were able to do and why we were successful. But I think I also should talk about areas for improvement and things we identified that we could do better if we were going to do this again, or we're going to do when we're taking on another large project. Number one is identifying metrics for success and figuring out how to track them. Were we successful? Yes. Can I tell you exactly why? Besides the fact that we migrated a network and it worked. No, I don't have any metrics. We didn't think about metrics ahead of time. Also, where did we fail, or where could we have improved? And I don't know, because we didn't have metrics. So something we're going to think about going forward is, what are those metrics and how do we track them? Another one my boss has mentioned multiple times is developing team dynamics. Again, our team was really spun up for this project. We're a team now going forward. We have a lot of other work, but we brought a lot of people together and immediately threw them into NSO and other automation efforts. And it worked really well. We have the right people, but it still would have helped to try to develop those dynamics. I think he has said, some of us, between all of us, we've been together 18 to 36 months, and we haven't really started to gel until the last 9 to 12 months. And so it would have been nice to, have more time together. Obviously, that's not always a possibility, but, I think going forward, we'll be successful as a team because we've had the time to develop together. And the last one is more outreach and education, especially to our to our engineers on the network team. As I mentioned, we had this design team with core network engineers. We were working constantly with them. They knew how NSO worked. They knew how the models worked, but we weren't really going out to the rest of our network engineering team to show them what was happening or really show them NSO. So we've started to do that some more. We're starting to do training, but it's definitely something that we need to keep track of, and we need to do more of. All right, well, thank you for your time, and thanks again to Cisco for inviting me to present. Feel free to reach out to me if you have any questions or want to chat about automation.